Thank you. The huge advantage of being last at a conference is that, one, I don't have to wake up early. Two, I get to criticize the other talks. This time I don't want to criticize anyone, but I was at this talk about OOP. Who was at this? OOP is that talk, right? Okay. Not many of you, but a few of you. And that reminded me of a story. So I'm going to start with that story just to warm us up. So this is from Anton von Staken. And he wrote in a rather obscure thread in the 90s. This is a koan. Koans are these Buddhist short stories that are meant to spark thoughts. Like, they don't tell you the answer, but they are meant to start you contemplating. So this koan, as this koan goes, Juan and his students were walking on the seashore when the student says, "Master, I have heard about these objects. I heard they are really good." And then the master says, "Foolish pupil, objects are merely the poor man's closure." The student is shocked, goes away in shame, and studies closures and object orientation for weeks on end. And then finally, when he walks again on the shore with the same master, trying to impress the master, he says, "Master, I have studied functional programming and object orientation, and now indeed I understand why objects are the poor man's closure." The master gets really angry. Hits the student with his stick and lashes out at him. "Foolish student, when will you understand that closures are merely the poor man's object?" And in that moment, the student got enlightened. Okay, so with that con, has nothing to do with my talk, but I still wanted to tell you about it because this talk is slightly different and it has to do with microservices, but really any inter-service communication and even, as you will see, just plain old database stuff where you have lots of stuff going on at once. And the reason I wanted to do this talk, I did this talk a couple of times about 10 years ago. And then I was like, okay, everyone knows this. I'm not going to talk about it again. And right now I'm coaching people. I have a coaching program. And two of my students had the same issue as I had. And they didn't know about the Saga pattern. And I was like, okay, it's time for me to do this talk again. So the story goes that for weeks on end, I was waking up in the middle of the night to pager duty. Who is on pager duty? Do you like waking up at night? I don't. And that's not the behavior that I was expecting, yeah. So really nice mouse, but right now I just want to present. Okay, so I was sitting up in my bed trying to fix these errors, and I was tired and I had no idea what's going on. But really, our problem started earlier with the monolith. Because, you know, monoliths tend to, we had all these dev teams, like 100 people working on the same code base, and basically we were stepping on each other's toes, and what was even worse is that the ops team, like we had a separate ops team. They were called DevOps, but that was a lie. They were just an ops team. And they were completely overwhelmed with alerts. So at some point we decided that we just cannot go on forever. We need to do something, and we did what everyone else was doing at the time. Yeah, that's how we approach this. We're finding dev ops problem now. Not a great attitude. So we decided that it can't go on like this forever. So we started breaking out microservices. These are little microservices there. And at first it looked really nice. Problem was that the service that I was working on with my team was the conductor. And you can tell that the AI image generator understands conductors very well. um, so by that I mean that we had this kind of workflow engine where you would have these little boxes that you could put next to each other. They would do certain things, and you could connect them. And one of these programs was like, we got the recipients from the database, then we sent them a message, then we waited for 2 days, and then we filtered them. And the way we filtered them was we selected the ones who didn't respond to the first message, and then filtered them down to a select VIP customers, or best customers, who would then get a huge discount. There was one problem. One day that filter broke. And it didn't filter down to the VIP customers. Indeed, it just filtered out the VIP customers and no one else. And everyone got a discount. I mean, the client was, of course, upset. They asked us how much money are we willing to help them out with after creating a sale for them. And you know, when my first reaction was at the time, and this was a dumb reaction, but my first reaction was, your service was crap. And it's not on my business that your service broke, and now I'm being responsible for my beautiful service doing all these other things, like conducting this thing. That's not my problem. But here is something I learned from my ski instructor. When you go skiing, you can be sure of one thing. You are going to fall. You are going to fall a lot. And if you don't know how to fall well, you are going to injure yourself. I learned this the hard way. The first time I went skiing, I tore my ligament there. So you have to know how to fall well. And so when you learn skiing, the first thing you learn is how to fall. And that's the same with microservices. If you are calling other services, you have to accept that they are going to trip you up. And you have to prepare for those issues and treat them well. So the rest of the talk is going to be about that. How do we do that? And it will have 3 parts. The first part is the journey, where I will tell you all the bad ways that we try to fix the problem. The reason I'm doing that is because every bad way is going to tell you, what is it that was missing from our naive solutions, so that we will understand during the second phase why all of those complex details are necessary. Because in the end, the Saga pattern is a quite complex beast, as you will see. And then finally, if we have time, I will go into some of the implementation details. If we don't have time, I have good news. A video on my YouTube channel is coming out, and that will contain the implementation details as well. But I might get to it anyway. So let's start with the journey. So here is a simple example. We have a car rental company, and we want to rent a car. So we go in the database, we check the availability, we reserve the car, and assign it to a user. If you design your database well, this would be one query. Let's assume this is a badly designed database, and this is 3 queries. This is all fine until your program crashes halfway through, and then you don't assign the car. Because now you have a car that is reserved but not assigned, right?
So what's the difference between reserving it and assigning it?
Reserving is like putting a check mark next to the car that on this date it's used. And then assigning is inserting a line that says that this car is used by this user.
So that happens on the day when they actually take it out?
No, that's in the same process. But that's not really the important part. The point is that if I have 3 queries, 2 of them are done, and then process is dead, then the third query might not run. That's what I'm trying to get to this with this example. And you are probably shouting in your heads, why wouldn't you use transactions, right? Easy. And you're right. That's how we do it. Okay, but then what's the problem? Well, the problem is that we don't just have a car company, because we are organizing a ski trip. I love skiing, by the way. Did I tell you that? So we are organizing a ski trip, and we need to get a plane ticket to fly to Innsbruck, and then from Innsbruck we are going to drive to the ski slopes. We need a hotel, and we need a ski pass. Problem is that all of these are organized by a different company. So now we have to make API calls to all of them. Good luck with putting that into a transaction. Okay, so basically we have 2 problems. One, we would have a really long transaction because all of this internet connectivity slows things down. So we would have a lot of locks going on. It's just not sustainable. And the other problem is there isn't even a single database to do a transaction in. So what's the next best idea that we can do? We surely just didn't ignore failed queries, right? We surely just didn't ignore them. Yes, we did. I'm not going to go into details of why that's a dumb idea, but that was our starting point. And then the next idea was, okay, if we can't ignore them and we cannot have a transaction, what if we triggered an alert when there is a failed transaction, and then we stopped everything, and then whoever is on call will fix it? Great idea. Try it. For plus points, try it on a system that has millions of transactions an hour. You will learn the hard way. So yeah, that's not such a good idea. Okay, but there is still hope. Like, we can do brute force recovery. So what you can do then is your genius idea again. It didn't work first time, right? But we already learned during when we got the pager duty alert, and then we just retried it, and it immediately worked. So why don't we just automatically retry it? Like, just hit the database or hit the API with 100 requests, one of them will work. Problem is that if you hit a service that isn't responding because it's overloaded, if you hit that with 100 more requests, that doesn't really help. Okay, so we are getting a bit closer to our goal. So then we learned about exponential backoff. Oh, that's great. So we can be a bit smarter. We are not going to hit it right away. We're going to put it away for a while, wait a bit, come back, try again, and then maybe it works. And then if it doesn't, then we wait a bit longer, and then try again, and so on. Okay. That actually is almost there. Like, it's already getting there, but it still has problems. What are the problems with that? Yeah?
Well, maybe it's not just that the server's down or overloaded. Maybe it's that there aren't any steep passes left, or there aren't any.
Exactly. That's a problem. Like, sometimes, no matter how many times you try, it's still going to fail. So in that case, you actually have to somehow do things like turn things back, right? So we are back at this damn transaction. Okay. At that point, when we got to this point, I was like, okay, I'm going to read up on distributed transactions. Like, maybe I shouldn't invent the wheel, even though I like inventing wheels, but like, you know, I was already tired and exhausted from all the alerts. Maybe it's a good idea to read up. And when I did that, I learned about two-phase commit. So two-phase commit is a very simple idea. What happens with two-phase commit is you go to every single service, tell them what you want, And all of those services are going to keep the transaction open. While you are going around and asking everybody, those transactions are open. When everyone decide A-OK, then you go and commit all of the transactions. What could go wrong with that? Let me give you an example. So, other day I went to a restaurant with my friends. On this picture, this is 3 of us, but really it was 20. And then the waitress came and took our orders, and then she went back to the kitchen and asked the staff there to prepare the meals. There's just one problem, like 20 of us had their meals ready really quickly, and then one person's meal took forever. So 1.5 hours later, we were sitting with cold and yucky food in front of us, except for that one friend who was really happy with their food. What's the problem here? And you know what's the worst? Like, there's a long line outside the restaurant right now because we were holding the table for 1.5 hours, right? So that's the problem. Like, you have this long transaction, everything is locked up, and what's even worse, the waitress might actually forget that she took the order. So then we also have a single point of failure. So long transactions, so the waitress forgot it. We also have single point of failure. And that was the point where I was like, okay, we are getting close. But when I was reading up on this topic, I didn't find the right answer, unfortunately. I found out about it a year later when someone told me about the Saga pattern. So we have to reinvent it ourselves. But I'm not going to tell you right away the way I reinvented it. Instead, I will tell you the right answer, and then we will get back to the slight difference to how we did it. Okay, so enlightenment. What if we didn't stick to ACID? That's the big question, right? Because transactions are known for the ACID properties. What are the ACID properties? I have a slide for that. A is for atomicity. This basically means that it's an all or nothing transaction. Either everything was successful or nothing was successful, and there is no in-between state. Consistency is we are always in a valid state. Whatever happens, no one can come into the database, make a query, and get an inconsistent result. We have isolation, which means that any transaction that is not committed appears for everyone else as if nothing has happened. Like, think about this. This is a very weird property. I made an insert into the database, but I didn't commit it. And then another person comes through another connection, and they don't see the thing that I inserted until I have committed. That's isolation. And then finally, durability, which is committed transactions are written to the disk and nothing can happen. Okay, so what I want you to think about is which one of these are we going to lose? Because now I'm going to show you the correct solution, and some of these will be gone. But which one? So, as I said, we had a slightly different solution. I'm going to talk about that later. But now let's reach the summit, and let's talk about the Saga pattern. Our goal with the Saga pattern is to break up large transactions into small transactions. And that's the crazy stuff about this. This Saga pattern was invented in the 80s. That's much later than most of computer science, which was invented in the 60s and 70s. But it was invented in the 80s. And in the 80s, they weren't dealing with microservices. Their problem was that they had all these long transactions that just logged up the database for too long. So they came up with Saga pattern to break up a long transaction into smaller transactions. And of course, as a side effect, we can actually have it in different databases. That's actually just a happy side effect of the Saga pattern. Let's organize a ski trip then. This is going to, let's walk through the ski trip organization as if a human was doing it. Like if I want to organize a ski trip as a human, what do? I call all, like the airline, the car rental, all of these companies, I call one by one on the phone, okay? If everything is good, I'm done. This is the happy case. So far, it's fire and forget, right? Okay. What if the hotel is full? So I call the airline, get my ticket, call the car rental, get my car, and then it turns out that my favorite hotel is full. Now, I may try to find a different hotel. But I'm autistic, and I really want to stay in the same hotel because I hate change, okay? So I don't want to stay in a different hotel. And also, like, that means that I don't have to make a decision about another hotel, right? This is good. Our algorithm shouldn't make decisions without the human in the loop. So we need a different solution. What could be a different solution? Well, I can call the car rental company, hey, you know, I rented that car a few minutes ago. Can we undo that? And the car rental company says, like, yeah, weird person, but sure. And then I go to the airline and try to call them. But the line is busy, so I can't reach them. I mean, it's a problem. Like, I still have a plane ticket, but you know what? I'm gonna go take a walk, come back, try it again, and then they take the call, and I can cancel my plane ticket as well. What you have seen is the Saga pattern in action. This metaphor contained all of the parts of it. So let's go, like, when I was listening to the talk at this conference, I felt like you really like academic definitions, like really theoretical stuff. So I brought you theoretical stuff. Here is your proper definition. A Saga is a sequence of independent actions with idempotent compensating actions. Now, probably you are smart folks. I'm not smart. I don't understand this, so let's break it down. Sequence of actions is basically just what we did, like calling different APIs, for example, is a sequence of actions. Point is that it changes the state in some way. Okay. What does compensating action mean? Almost. Here, and you're right. You're absolutely right. It's an undo. But compensation doesn't mean perfect undo. It means that it brings us back to an acceptable state. To give you an example for an acceptable state, when I canceled that flight, the airline might say, yeah, you can cancel your ticket, but we are not going to refund you. You will get like a credit for your next flight. I might be annoyed by that, but I'm going to take it, right? It's an acceptable state for me. Maybe it's not for you, but the point is that with a compensating action, our goal is not to do as if nothing happened. We don't need that for the Saga pattern. It's enough if it brings us back to a consistent and acceptable state. Okay? And then there is this word idempotent. You just heard about it. But this idempotent is a slightly different idempotent. Because what we heard in the previous talk, that idempotent is like you expect the sorted array to be still sorted, that like the exact same thing. This idempotent is more like that compensating action thing. Like, I'm okay with it being a slightly different state, but it should be just as good. Like, I don't want the repetition of that action, like doing the action twice shouldn't result in something that is substantially different in a way that bothers me. Okay? Okay, so we have all these in place, but yeah, I just explained idempotent. Operation is idempotent when applying it multiple times is equivalent to applying it a single time. And as I said, in our case, equivalent can be a bit fuzzy. So a few examples. Canceling a plane ticket by ID. That is idempotent because I have an ID. If I call the airline again, please cancel this ID, they are going to be annoyed and tell me that I already did, but it's fine. Let's look at a few more examples. And this time I want you to put your hands up. So who thinks that ordering a pizza is idempotent? Who thinks it isn't? Yeah, right. Okay, how about eating the remaining pizza? Is it idempotent? Put your hands up if it is. Yeah, because if I don't have remaining pizza, end state is the same. Okay. How about reserving a hotel room? Is it idempotent? Who thinks it isn't idempotent? Yeah, that's correct. We don't want 2 rooms. But what if I asked you to reserve room 404 for tonight? Is it idempotent? Yeah, okay. One last one. No, actually I have 2 more. Cancel the last reservation. Is it idempotent?
Depends.
Exactly. It depends how we implemented that last. But cancel reservation ID, I ate pizza. That's fine. Okay. All right. So we definitely understand idempotency and Saga now. My next question is, what did we lose, and how much time do I have? Okay. Sorry. Yeah. Very nice. Very nice. Atomicity. We did lose that. Actually, that's the first one on my slide. Yes, we did lose atomicity entirely. But how about the others? How about consistency? Do we still have consistency? Yeah?
It's exactly what you said, but it's not consistent with the previous statement.
Yeah. Yeah.
It's eventually consistent.
Exactly. That's the word we're looking for. So it's eventual consistency that we get. Like, it might be inconsistent from time to time. It's fine. I don't care. As long as long-term it is consistent, it's fine. Which, by the way, means that your database is never in a consistent state. Like, eventual consistent is never consistent, but always just a little bit inconsistent. Whatever that means. Okay. How about isolation? Do we have isolation? Yeah, it's that definitely no. Like, it's everyone sees everyone else's transactions, right? How about durability? Once the Saga is done, everything is written to disk? Yeah. Yeah. That's the only thing that actually is unchanged. We lost a ton of things, but note that we didn't entirely lose them. Like, yeah, for isolation we lost that entirely, but consistency, we still have kind of consistency. And I'm also going to show you something instead of atomicity, because we don't have atomicity, but we have something else. Yeah. The important thing is that we gained availability. Now we don't have to worry about things locking each other up. We don't have to worry about processes dying. That's what we gain. So this is the thing that we get instead of atomicity. And it's a really interesting concept. It starts with the first option. Either everything is successful. We like that. Or successful actions are compensated. Thanks. What does that, like, if you look at these two, what does that sound like? To me, that sounds a lot like atomicity until this point, with the slight caveat that it's not undone, it's compensated. But until now, it's almost atomicity. But there is a third option. We are in the process of executing actions. So, and that's the thing that we gain instead. So the beauty of the Saga pattern is that it doesn't entirely give up on transactions. It kind of, it just breaks up a big thing into smaller transactions, and in between the transactions, you get this fuzzy, almost transaction. And that's why it's a really important concept if you deal with any kind of services. It doesn't even have to be all of your services, as we have seen. Like, it can be also from other vendors. Okay. But there is one question. What if an action cannot be compensated?
You have to put it at the end.
Very good. Exactly. That's what you do. So, for example, an email, once I sent an email, no matter how annoying that is or how ashamed I'm of that email, once I sent it, it's kind of done, right? So the way you do that is actually how we did, like our solution was very similar to that. And that's called the forward recovery. And basically you can break your Saga into two different sections. The first section is just the compensatable actions. You do all of those. Once all of those are done, then you start executing the non-compensatable actions. The important caveat is that if an action cannot be compensated, that it has to be it has to be guaranteed that it can be done. Like sending an email, that's going to be eventually good, right? Because what we are going to do is, instead of trying to undo events, we are going to try and retry and retry. So all of the things that we know cannot be compensated for, but are eventually successful, those go to the end, and that's forward recovery. Okay, so I have about 8 more minutes, if I'm correct. That's a bit tight for the digging deeper part, but I'm gonna try. Worst case scenario, I'm not gonna finish. Okay, so for the actual implementation, you will need 2 things. One thing is the Saga log, and the other thing is the Saga Execution Coordinator, or SEC. The Saga log is a durable record of independent actions. It's basically you writing up what you have done and what you have undone. It is a single source of truth, but should have a fallback. So typically, your Saga log is going to be in a sharded database. If you use MySQL, I don't care. If you use Redis, I don't care. But it should be written to disk, and it should be a sharded database. Okay? The other thing that we have is the Saga Execution Coordinator, which is a stateless and fungible process. You're functional programmers. You love stateless processes, right? So this process is processing the Saga logs, and it may fail and restart at any time. That's the important thing about it. We don't want it to be a single point of failure. It can fail, it can crash, it can burn down, it will restart and continue where it left off. Let's look at the happy path, how that works in practice. Our Saga log starts with the task list. The Saga Execution Coordinator reads the task list, writes begin Saga to the end of the Saga log, and then it writes begin task 1 to the end of the Saga log. Once it has done that and committed the transaction, then it goes and talks to the airline. It actually does a transaction, comes back, thanks, and writes done to the end of the Saga log. Writes begin, second task to the end of the Saga log, goes, rents the car, so on. it does everything. Then if everything was successful, at the end it writes end Saga to the end of the Saga log, and we are done. So that's the happy path. How about the unhappy path, failure case? So let's assume that after we did task 2, we are going to begin task 3. We go to the hotel, and while we do that, this whole thing fails. Either because we couldn't talk to the hotel, or because this process crashed after it has talked to the hotel. We don't care. What happens is that this process is gone. The Saga log lost its process. So now what happens? We start another instance of the Saga execution coordinator. It will read the now incomplete Saga, and it will say, okay, so it was something, we began something, we don't know if it's successful. My safe move here is to abort the Saga and start undoing everything, or compensating, to be more precise. It writes begin compensate, goes and tries to compensate. It fails, maybe, but no problem, because when another instance of that Saga execution comes back, it reads the log, notices that we already aborted and started compensating, and it just simply goes on and keeps compensating until everything is compensated. That's the high level, or the actual way we implement this. You probably shouldn't code this yourself. Almost every language has a ready-made Saga library. So if you have one, use that. So when should we apply compensating actions? Basically, there are two main cases. Either the Saga log ends with begin, or like that means that we began one of the actions, but we don't know if it finished, or if the Saga log contains an abort, because that means that something was wrong anyway, so we should go back. Okay, so I'm going to finish in 3 minutes. Okay, so what if an action isn't idempotent? So not every action is idempotent by default. We have seen that, right? For example, the email sending was one example. If that's the case, then we can use transactions and a unique action ID to make it idempotent. And this last thing I want to show you is how you do that. So we will have an action ID registry, and we will put every action ID into that action ID registry. It's a table with a unique key action ID. It's important, there's a unique key on it. Okay, so happy path. Request comes in, we start a transaction. We insert ignore by unique key. Okay? This is the part where the magic happens. We insert ignore by unique key. If that was successful, that means that we haven't executed the task yet. We perform the action. If it was successful, we commit the transaction, because remember, we are in a small transaction within the Saga, and we respond with OK. So that's our first case. The interesting case is when that unique key violation happens. Because if the unique key violation happens, that means that we already committed the transaction with that unique key. So we are perfectly allowed to say, OK, we have done it. That's the case when the annoyed person tells us that we already canceled the flight. And then the last option is any other error happens, we know to roll back the transaction and respond with a failure. And with that, just 2 things that I want you to remember from this talk. One is whenever you have a long-running distributed process, use the Saga pattern, look up a library, and use it. If you don't find a library, reach out to me, and I will help you write it. I'm on a mission. Like, we are going to open source it if you want me to help you, but this has to be in every language, okay? The other thing is whenever you make APIs, for every endpoint, think of idempotence, please, because someone on the other side will thank you for that. And with that, I'm going to thank you and let you know that my YouTube channel is Next Increment. I have a workshop called Lean Poker. Not going to talk about it because I'm out of time. And if you go to ivettördög.com, You can find all of my all the ways you can access, reach out to me, or get coaching or whatever. Thank you.
Thank you very much. So we have 4 minutes time for questions. So are there any questions?
Yeah.
To me, okay, in the real world, it happens quite often. Let's say that I see a sofa in the shop window that I like, yeah? And I go in and I say, well, I think I'm going to buy it, but the wife's got to agree to it. So give me an hour, I'll go get the wife. If you don't hear from me by tomorrow, sell it to somebody else.
Yeah.
Now in this case, there's an extra thing that's missing from your model, I think, which is that I get a provisional booking, but if I do nothing, I lose it. I have to do a further action to secure the booking. And that
Yeah.
often, that certainly applies to hotels, I think it applies to a lot of other things involved with holidays.
I really like that idea. I think that that could actually make the I think that's a specific version of how you can implement compensating actions, right? Because
Well, the difference is that you have to do a further action.
Yeah,
to
that's true.
change the booking
That's
into
true.
a
Yeah.
real booking.
okay, that would be an interesting variant on the Saga pattern. Yeah.
I think it's even more specific if you buy concert tickets, for example. They are reserved for 15 minutes. You have to pay within the next 15 minutes, and then the reservation is reversed. So we have a time constraint on this.
Yeah,
transaction.
yeah. I mean, I don't I think that this is an interesting variant. The original Saga pattern doesn't talk about this, but I love it. And probably if I do this talk again, I will just include that.
It's just a different failure case, though. I mean, you still result in the same result. You have an error. It's just that there's something that has to monitor that expiry time.
Yeah, yeah.
Which
Or,
is no
same as
different
life,
from
Yeah, and actually there is that other option of I can turn this around, right? I can either say I have a conditional like temporary reservation on thing, or I can say let me take that beautiful suit home. I'm gonna show my wife, and then when I go back and if she doesn't like it, I bring it back and say, hey, my wife didn't like it, and then I get my money back. That's
Well,
another
the
option.
case yeah, that's covered in the Saga pattern,
Yeah.
things like that.
Yeah.
Whereas sometimes it's the sort of
Yeah, but
hotels
yeah,
that you do.
I think that's fairly easy to add to this concept. Yeah.
If you work with unreliable protocols underlined, it doesn't really kind of save you all cases, because there is always possibility that there is a timeout and the timeout was successful for the other one, but the acknowledgement kind of died.
Yeah, yeah. So the Saga pattern doesn't solve every case. It reduces the number of errors significantly. So one example is sending the email. I cannot put the email sending in the transaction. So if that happens, then I have to accept that there is a minuscule chance that after I inserted that or committed that unique key in the table, that the email still fails, right?
Yeah, but what I mean is if your email has this, have you seen, then respond back to me, and
Yeah.
you may lost these kind of acknowledgements. anyway.
Yeah. There are probably a lot of edge cases that we could still add. Yeah.
Okay, so
But-
last one quick question.
I'm just curious, do you need the Saga mode? Like, you just have what you're trying to do, you can book hotels and everything.
Yeah.
And if you fail, can't you just ask them, hey, did I book a hotel? Did I do the thing? And can you just recover?
I guess you could implement it that way. I think it would be quite challenging because most of the time the compensating action requires you to have the ID. So I think it could be done in some cases, but this variant is probably more secure.